Hello and welcome to another tutorial on dev.java website. We're looking at the getting started with Java, and we are looking now at the adding code to your class to run. So we look at the concept of compile and execution. We looked at the setting up the JDK, setting up the path environment variable, and setting up the Java home environment variable. And now we have created our own class. And then what we want to do, we want to add more code. And it's very easy. Basically, in your ID, you right click and then say new class, and then say my first class, and then you ask it to add main. And then the other thing that you need to be very comfortable with doing is using code templates. So templates, basically what this means is that instead of writing so what we want to do now is to write something to the console, right? So let's say we want to write to the console hello world. So all we do is we write one word sysout and then press enter and then say hello world, right? So as you can see, Java is very people always complain that Java is verbose, but that's because they don't know how to use their power of IDE, right? So Java can be the least verbose programming language, right? That's just because of the amazing IDEs for Java. And really nothing beats Eclipse IDE, right? So Eclipse IDE is the best. I mean, this is subjective, and this is kind of my own, or basically it's kind of my own personal opinion because I grew up with Eclipse IDE. But the fact that Eclipse IDE is so powerful, it took us one click of the mouse to create this. We didn't even need to type this main because we already asked it to add a main, and then we typed sysout. So two words, one mouse click and typing one word, sysout got us to all this, right? So I mean, you cannot really do this in any other programming language, just doing one click and then typing one word sysout to get all this code. That's the power of IDEs. And really Java, without IDEs such as Eclipse, Java, or in general programming, doesn't have much meaning. So programming languages that don't take advantage of IDEs, such as dynamically typed languages like Python, they really are kind of when you get used to all these nice features of IDEs, you realize that those programming languages are easy to type like 50 or 100 lines of code, but then when you end up with managing 1 million lines of code, you realize that statically typed languages and IDEs are the best, right? So let's go back to the website. So adding code. So far your class is empty. There is no executable code in it. If you were able to compile it properly, then you can advance to the next step and execute some code. Just open your myfirstclass.java right here, and then and copy the following code in it. And again, you don't need to copy anything. You just go to your Eclipse and type sysout, right? Sysout and enter, and it automatically says system out print line, which is very convenient. And if you want to add more templates, let's say I want to say type my sysout, and it does basically the same thing. Maybe so sysout always adds the print line, which means it adds a, so if you look at the documentation of print ln means line, so this means print line, and this means that after you type, for example, whatever a string, whatever argument that you put here, it adds at the end a /n, which means it moves the carry to the next line. Well, let's say you want to have another template that doesn't do that. It uses the print or printf function, right? So printf means print formatted text, right? All programming languages have this printf function. Java also provides that. C has it. So in C, you directly, it's a built-in function. So built-in function printf. And then usually in C++, obviously C++ inherits all the stuff from C. So in C++, this printf is also a built-in function. You don't need to add any library, any header file to access this. But as you can, and as you already know, in C++, the recommendation is to use stdc out and use the overloaded insertion operator, right? But in C++ you can also provide print. So as printf is like this. So system.out.printf, no, not print line, print f, right? So a string which uses format specifier, so you need with printf you have to use format specifiers. These are placeholders, right? And you specify them with %. %d means digit or decimal, integer. %f means float, and you can specify, for example, let me go or move to the next line. For example, if you want to say that float with 2 decimal places or 2 places of accuracy after dot point, you can tell this dot 2, right? And then %s means a string. Now in Java, it's the printf is intelligent. So if you put an object and specify it as a %s, what it does, it calls the toString method on that, which is very convenient. For example, we want to say %s and then we type true, for example. Now true has a basically toString version. So if I do this, it automatically prints true, right? Now in C, for example, if you use printf and this kind of notation, I believe it throws an exception or complains, or maybe it doesn't even compile. But in Java, it's intelligent enough to know that if I pass an object, for example, args here is a object, right? And it tries to call the toString method on this. So at this point, it looks like it's not doing it. If you so for example, anything else, let's create an object. Let's say test2, for example, test2, new test2. We have this class. So what happens if we specify it with toString, something like this? And as you can see, it calls the toString method on it, right? So it's intelligent enough to know that everything in Java is object. Every object has to have a toString method. So if we have a string specifier, format specifier for an object, it's basically calls the toString method automatically. Now let's say I want to create a template that instead of saying sysout, so sysout always uses print line. Let's say I want to say sysout f, which means I want to use printf, right? So we go to preferences and then search for templates, general editor. So we want to go to Java code style, code templates, right? And we want to go to editor templates under the Java. So Java editor, right? We want to be in the Java perspective, and then in the editor we want to have templates. And let's look for sysout. As you can see, sysout here, system out println, and these are the environment variables or the global variables that Eclipse understands, right? So if you want to do this kind of generic programming, you have to be familiar with these environment variables that, or basically the global variables that Eclipse understands. So these are specific to Eclipse. For example, dollar and then these curly brackets means this is a variable, and this variable is not a fixed value. It's a variable at runtime. The value is passed here. So word selection or cursor, right? So what we want to do, we want to add a new one. So let's copy this line and add another one. Let's type this context. We're going to set it exactly the same as sysout, which is a Java statement, and then automatically insert. And so we're going to say printf, or in the description we're going to say printf to the console, right? The sysout says print to the standard output, so printf to the standard output, right? And then the name is sysout f, something like this, and the pattern is going to be this one. We copy and paste this, and instead of saying a system out println, we say printf, right? And then okay, so this looks okay, and let's hit apply and close, and let's try this. So sysout f, now we also have this. So if I type sysout, I have sysout print to a standard output, sysout f printf to the standard output. So if you select this and then the cursor comes here, we're going to say %s and test2, right? And then we pass an object here, and then hit enter, right? Okay, so test 2, we have to rename these test 2, right? So you can take advantage of these very powerful templates, so that then Java becomes pretty much less verbose than other programming languages. You have to know your IDE. That's the only way. I cannot emphasize this enough. Before learning Java, you have to start learning your IDE first, right? Learning your IDE is the most important thing that you can do in your life, right? If you're trying to become very good at Java programming or any type of programming that involves a statically typed language, you have to learn your IDE. All right, so going back here, so we create this class, add the main, and then do a sysout. And obviously for main, we don't need to type all these, right? Because there is also a template for main, which you can already guess. We type main and it tells us there is a template here, public essay. We just hit enter and that's it, right? So we just type one word and the IDE automatically does the job for us. Always rely on your IDE. Don't rely on saying that you are more capable than your IDE. I mean, these two go hand to hand, right? You have to be a good friend to your IDE to really be able to take advantage of Java. As you may know, there is a long-standing tradition in computer science, which is to write a program that prints hello world on the console of your application. So let us do that. Then the console means terminal, and as I mentioned before, operating systems are very simple, right? Whatever you run, it runs. Whatever application you run, it actually runs in a terminal. Terminal is the gateway of your communication with your operating system, and the operating system is the gateway to taking advantage of your hardware resources, right? Operating system is is what is sitting between you and the hardware. So everything runs in a terminal. Every terminal has a PWD, print working directory, which means whenever you run a command, you always run from a working directory, so that if your application outputs something to the console, it will print it to the console as text. Console is a purely text-based application. It doesn't understand anything other than text, right? And then we talked about environment variables and also local variables, and we said that you in a console session, whenever you open a console, you can define environment variables. Those are used locally. As soon as you close the terminal and create or start a new session, those local environment variables are gone. That's why for more permanent variables like Java, home, or path, you want to define them as global, which means you save them in a file that whenever you run a terminal, those files are automatically loaded. So hello world, so system out print line, system is a class, and then out is a object, which is a field inside the system class, right? And let me open up the system class. Java lang, it's automatically imported. Anything inside the Java lang is automatically imported, so you don't need to have any manual import for the system class, right? And then if you look at the fields here, right, as I mentioned before, any symbol on the outline that has a white dot or a star or plus, whatever, it has a white dot in it, it means it's a field. Anything that is a field symbol, like a green or rectangle, but there is no white dot, it means these are methods, right? These are fields. And this is a very nice, easy to use visual cue about understanding the class structure, right? So we have in, out, and error, right? So these are the three standard streams that the consoles work with, right? So there is in, out, and error, and this mainly pertains to Linux based or Unix based operating system like macOS and macOS and Linux. But Windows, I mean, Java has to be platform independent, so they kind of map these three to the other streams that the Windows terminal supports, right? So in, out is a static public field, it's final, and as you can see here, is by default is null. And what happens here is that this is whenever you run the JVM and JVM loads this class, this is automatically initialized by the JVM. So there is no actual Java code that initializes this. This happens basically during runtime, right? So the standard output stream, this stream is already open and ready to accept output data. As you know, all the streams have to be closed. Streams means we are taking advantage of the hardware, right? Maybe a file stream, we have to open the file, which means we're using some of the hardware resources, so we have to close them when we don't need them. But the console is an exceptional case of or an exception to the rule, because whenever you launch an application, again, you launch it from the terminal, or there is always the assumptions that the operating system knows that your application has to be able to communicate to a terminal. Even if the user doesn't see the output to the terminal, a standard output must be provided by the operating system to your application. So whenever I run this Java application, the operating system allocates console to my application, right? So that my application can output to the console if needed. There is technical code in this class that may not be very clear. Do not worry, all you need to do is to compile it following the steps described in the previous section. Make sure that the compiler created the my first class.class for you. As I mentioned, every class definition is compiled to a class file, right? If we have multiple class definitions in a Java file, the compiler will create separate class files. Again, this is the reason I repeat this, because this is a very fundamental concept, right? It doesn't matter if we have an inner class or two classes in the same Java file. It doesn't matter. Every class has to be compiled to a separate class file. And we said that in a source file, in a .java file, there can only be one public class, right? And then the name of that source file, that Java file, must be the name of that public class. Now, obviously, you don't need to have any public classes. That's fine. But then that limits the accessibility or visibility of your code, right? So if you want to make it public so that it's accessible outside your packages, you have to make it public. And then there is a condition that only one class can be public. And the most reason for it is that you don't want to end up with a circular dependency, because if you import one class and then later on something happens, some imports happen, and then you end up with a circular dependency, you don't want that to happen. That's why I believe they enforce this rule that the name of the Java source code must match the name of the public class. So we have this class file. To run it, all you need to type is the following command: Java my first class. And what happens here is that so if I open a terminal at my project, right, and we want to launch a JVM, and Java virtual machine is what is actually loading the class files and executing your program, right? And the JVM is just Java command, right? And you want to make sure that you can access it. You either provide the absolute path to the Java application or a relative path, or use your path environment variables, right? And obviously the easiest way is to use the path environment variable, which means you just want to type the name. So you can always quickly check if the Java application is available on the path. Right now I'm using JDK 15. And then if I do ls, you see Eclipse puts the class files on the bean. So we want to go change directory into bean, and bean is the root of the class files. So we want to launch our Java JVM from the top folder of the class files, because that's the concept of packages, right? And then whenever you launch a Java from a folder, it adds that to the class path, right? And then you want to make sure that the packages are compatible with that class path. Otherwise, you have to manually set the -cp dot. We are in the bean folder, and then I'm going to say what we're going to do. We're going to run this class, right? Dev Java text, where you put the fully qualified name, and then we're going to say my first class, something like this. And as you can see, it executed the command. Now if I just go and say that go to the bean directory, but I say I don't specify the fully qualified name, right? Package and a class, and I just say my first class, it says I couldn't find it, because right now the class path is set to where? It's set to the bean folder. That's the correct thing, correct configuration that the Eclipse creates, right? Because of the package hierarchy. What this means is that if I go inside the Let's do a ls cd dev java and do a ls here cd text blocks, and let's do a ls. As you can see, my first class is here. So if I launch the Java JVM from this folder that has my class file, right, my first class, and obviously you don't add the dot class, and it still says I couldn't find it. So that's the question, right? Why is it that we are inside this folder that has my class file, but I cannot launch the JVM from this? I cannot launch my class that has the main method. So basically this is my Java application. I cannot do it. Why? Because JVM here says I couldn't find it. And the reason is the class path, the concept of class path. And the class path means how the JVM finds the classes, the path. And that's the reason that class path exists, because of the package hierarchy. These package declarations at the top of your Java classes, and they will be translated inside the JVM. These actually translate into actual path, and these paths are relative to the folders available on ClassPath. And I will discuss this in much more details in the next lecture, because this is the most important concept for high-level languages like Java and Python, right? In Python we have Python path, in Java we have class path, right? For programming languages like C++ or C, you don't have this concept, because you have to bring everything, all the header files, everything into your compilation unit, into your source file at the time of compilation. And after that, the linker links everything together. At runtime, there is nothing to search for, right? There is no dynamic loading of classes or anything like that for C++. But Java and Python, they rely on existing stuff at runtime, because there is no real compilation like what happens in C++. I hope you enjoyed this lecture. Please stay tuned. In the next lecture, we will look in depth at the class path and how to set it up correctly. And my recommendation is always is that to just ask your IDE to take care of it, because you write your code and run the Java application, Eclipse knows how to set correctly the class path. But it's good to also understand manually how to set it up. So please stay tuned, and I'll see you in the next one.